Yeah, camps on it. So let's start off. Quite an important part. Let's see how to do this. Areas and volumes. Hope everyone has resolved the paper and the assignments. End of the class, we'll discuss them. Now, so last class, right, we have done the basic integration and stuff. Now in physics, right, the most important way of using integration is especially when you have different elements. So let's start off with something simple. I'll show you one and then let's go ahead more. Let's say you have a disk, pretty common shape. ठीक है, disk of radius r. So we want to find area of the disk. Now everyone knows the formula for area of the disk, right? Pi r square. But how do we get that? So how do we can we use integration to get it? So listen how to do this. Who else is missing? Why are people late? They won't understand anything after 5 minutes. ठीक है. So after the PTM, what did parents say? Vojas is so happy. See, so how many of you are using Nokia mobiles? We have 2, 3, 4, nice, 5, 6. Acha, good change. Nokia people should give me some sponsorship actually. No, but seriously, that day, right? It does. I hope you understood. I was just not saying, like that. There are multiple things. I have seen, right? People who get into this good ranks and all are not the people who are geniuses, but who are consistent and who are, they have that attitude. Like, kuch bhi hua, I will put a fight. I will focus on myself and I'll keep improving. Anyway, so we did discuss. So let's see for this thing, disk how to take. So the biggest idea in integration is how do you choose an element? That is the biggest thing. Others, do keep your cams on. So for a disk, this is how we do. Consider a thin ring of radius x with thickness dx. Meaning like this. So listen carefully. Ideas are simple, but you should know, okay, we should do like this. If you know once, then you'll get the hang of it. So you take a thin ring like this. So at a distance x, we take a thin ring of thickness dx. Now, so if I consider an element here, So we got thin disk here, basically a thin ring with a thin thickness. This is X. Now take a scissor and cut it here. And I open this. What shape do I get? If I take a thin ring and cut it and I open this, I'll get a small rectangle like this, isn't it? Where for this rectangle, if you look at this inside circumference, this length would be 2 pi x. Does everyone agree with this? And you're saying this thickness is dx. That means this width would be dx. You're getting it? These edges are so small, you can actually neglect this error. That is the whole point of integration. You're taking the thickness to be so small, you can assume almost it is to be the same. Isn't that the whole concept of integration we did last time? When we took that rectangle, you are comfortably ignoring this small piece, because the dx is very small, isn't it? That is the whole concept of integration that we have. So what do we got here? So we got this dA, which is the area of this thin ring, which is length into breadth, which is length is 2 pi x and breadth is dx. This is the area of the ring. So you want area of the disk. So area of the disk is add all the areas of the rings. We call it summation. So summation is nothing but integral. Now, what are the limits? Tell me where is the first ring starts from? The first ring starts when x is equal to 0. And then second ring, third ring, fourth ring, fifth ring, sixth, seven. Where is the last ring will end? When x is equal to r. So that is the meaning of limits. This is the area you're adding the rings from 0 to r. That is the meaning of limits. So if you keep it here, we get 2 pi x dx, limits from 0 to r. 2 pi is constant, it comes out. We have x dx from 0 to r. X dx is nothing but x square by 2, 0 to r. Therefore, we get area of the disk 2 pi r square by 2. 2 will cancel, pi r square. Just to give an example, how did we choose elements? You ever seen an onion rings? Ring upon ring, ring upon ring, ring upon ring. And what you get? You get a disk, isn't it? I hope you're able to visualize now. So if you see the elements here, what we have chosen, this is like, this is an onion made of thin rings. This is an onion disk. The idea was the same. Have a look at this once, what we did. Again, what I did, I'll show you. At a distance x, I took a thin ring with a small thickness dx. The thickness is so small, I can assume almost it is, negligible there. It's almost flat. And when I cut it open, I will get a rectangle whose width is 2 pi x and the length is 2 pi x and the width is dx. Area of a rectangle is length into breadth. That is the only thing that I know. So I got area of one ring. If I add all the rings, what do you mean by add all of the rings? Summation. Summation means what? Integral. Now tell me one thing. Isn't the integration quite easy? What integration is this? X power n dx. What was the headache? The headache was converting this into the integral form, isn't it? Have a look at the steps. So basically here, if you see rings start from x is equal to 0 and end at x is equal to r. That's where the limits are from 0 to r. That is the meaning of upper limit and lower limit. Where are you starting from and where are you ending? Any doubts on this? We just got the idea. Niharika, Abhinav, Adi, clear with this? Now there is another way to do this. See, you took this. If you take a ring, okay, rings and rings and rings like this. So what I would suggest, so take the outermost ring, so this will be how much? 2 pi r, the outermost ring. So from here to here, this radius is r. So now I will put all the layers one upon another like this. Then I'll keep the second ring, then I'll keep the third ring, then I'll keep the fourth ring, fifth, sixth, and so on, so on, so on, so on, so on. This apex will be O and this will be O. Is everyone able to visualize what I'm doing? You took out the each ring and you kept it one on top of another, one on top of another, you got a triangle. What is this height here? R, na? So what is area of a triangle? Base into height. Half base into height pi r square. Making sense? This, so there's no integration only. You could have used with the triangle and got the answer. Is this making sense, everyone? Vihan, what happened to you? Why are you late? You missed everything. Went to which movie?
Sir, I forgot that. Means I was expecting it to be at 6:30.
तो 7 o'clock class क्यों लेट हुआ? ये अलग ही level है. You should say, sir, you should say, sir, I thought class was at 7 o'clock. I came at 6:30, so that would have made sense. ये देखो, you thought class is at 6:30 and you came late to 7 o'clock class. I mean, explain the logic now. I'm confused. Vihan?
Sorry, sir.
No, sorry, no. I'm just genuinely asking. You did time travel.
No, sir.
Something like that. So, all clear with this? So we are talking about onions and how does onions affect Indian climate and how many onions to eat every summer. So therefore, in this weekend exam, onions will come. So Vihan, you missed all about onions. Okay. Let's see how to do a problem on this. So how will they frame questions on this? So if you see elements now, I was recently teaching, see, look at here. So there was a question like this. There was a disk which is rotating and kept it on a liquid, blah, blah, blah. Did you see how we choose elements? It's just not going to stop here. We will choose, questions will be like that. So the most important thing is, whenever you see the disk, what I want, it is okay, no, if you got bits and pieces of it, but the main thing is, did you understand till here that you can take a thin ring and you can write area is 2 pi x dx? If you got that, I think you got the main crux of it, meaning remaining parts are fine. So whenever you see a disk, the elements are rings. That is what I want you to know, meaning you have to take rings and integrate them. That is the main concept. Now, let's take a non-uniform disk. So let me show you one problem.
Show the previous page for a second. Thank you, sir.
Now listen carefully. Non-uniform disk. So we have a disk here which has a variable density, meaning mass is not same. So sigma, we call it surface density. In school you studied density, remember, which is mass per unit volume. So sigma is mass per unit area. Meaning, example, if someone tells you sigma is 3 kg per meter square, that is, if you get 1 meter square ka sheet has mass of 3 kg. That is the meaning of sigma. Getting it? So here we have a disk where sigma is equal to c into x, where x is the distance from the center. C is some constant. And x ka value lies between r to 0. Now, what is the meaning of this? Listen carefully. Listen carefully. I'll give you one more like this to do later on. Listen. So if I put x is equal to 0, sigma is 0 means what? There is no mass only, no? Means the center of the disk has no mass. As x increases, sigma increases. Meaning as you go away from the center, mass becomes heavier and heavier. That is, disk becomes heavier away from the center. Meaning maybe someone made this material now with a wood. Then maybe someone made it with maybe copper. Then maybe someone made it with iron. So if you see, the disk is becoming heavier as you go out. And if you go more out, maybe it is made of lead, which is even more denser. You are able to visualize how it is? So you have materials body like this, which is becoming heavier and heavier as you go out. So the outer ring has more density. The inner rings will have less density. Able to visualize how it is? So you can say your pizza is a non-uniform disk, isn't it? If you take a pizza is not uniform. Pizza is non-uniform disk. The edges will have more thick crust. The center is more thinner. And if you buy a pizza from like Pizza Hut or something, they're more thin and hopeless. Domino's pizza is more thicker on the edges. Pizza Hut ka pizzas are thinner. And wo Papa John's, though, it is even more thin. So your pizza is a good example of a non-uniform disk. Now the question is, for this disk, I want to find the mass. So let me show you one problem and I'll ask you one more like this. Now, what is the problem here? Why can't I find the mass directly? Now listen, the only formula you know is sigma is mass by area. That means mass is simply sigma into area, right? Agreed? Now for a disk, what is the area? Pi r square. So why can't I write simply mass is sigma into pi r square? The problem is sigma is not constant. Now every point has different sigma, right? How will I multiply directly? Isn't this the problem we faced in the integration? When you took a curve, the area of a rectangle was height into width, but height was changing every instant, right? That was the reason you couldn't directly say length into breadth is area of a curve, no? Are you getting the logic? The biggest problem we faced in integration in a curve is I couldn't say the length height into width. What is height exactly? Because height is changing everywhere. We are facing the same problem here. If I write sigma into area, great, but what is sigma? Every instant sigma is changing. Clear? So this is where integration comes. So this is how we start. So we have a lesson here. This is how I was teaching you elements before you came. So when you take a disk here, so sigma is c into x. Don't worry, we will do one or two problems. You'll get the grasp of this. The story is the same. From the center at a distance x, take a thin ring with a thickness dx. So just imagine you eat all the pizza ka center and leave the crust for your friend. Kabhi kiya? We do that, right? Normally, we eat all the piece and we just leave the crust. I mean, that is the best way to tease your friends. Normally, if you want to really tease your friend, the best thing is what? Go to a party, sit there, all of you order, eat, and make him sit in the center. We used to have one friend, matlab, this guy used to know, he's still there. This guy, we used to call him Psycho. His actual name is Saikant Verma. But अब इतना बड़ा name कौन बुलाएगा ना? तो Saikant Verma में we took Sa and we took Ka and became Psycho somehow. So we call him Psycho Psycho. He also does sometimes like that only. So this guy has a rule, on Saturday he doesn't eat non-veg. On Sunday he eats. So on Saturdays we used to have gaming nights. So Saturday we used to have gaming nights. This is when not in IIT. After we passed out from IIT and we were doing jobs in Hyderabad. So on Saturday we all friends used to come to one of my friend ka room, 3 BHK. We used to have full gaming and all. So evening 9 o'clock, 10 o'clock now we used to get biryani. Okay. And at 11 o'clock we used to take biryani. 11:30 ko na we used to start eating. And this guy used to go mad because uska rule ye na, you can't eat on Saturday. So 12 baj gaya to Sunday ho jayega. So IITians na, we follow rules properly. So iska condition is that once 12 a.m. passes, it is Sunday, so I can eat. This guy used to see his face, are ruko na re, half an hour wait for me na re, why are you guys eating karke? It used to be fun. We used to fight, I used to beat him, he used to beat me. That guy is an IAS officer now. He's an IAS officer, he's a municipal commissioner in Visakhapatnam, my hometown right now. So we feel that only. So last time his photo came in a newspaper. That municipal commissioner is doing something, blah, blah, blah types. So all friends were discussing in the group. Are Saikant, your photo came in the newspaper. How do you maintain that hair? We are all having hair fall. We are getting bald, but you have so much hair. Meaning no one is actually bothered about whether he's a municipal commissioner or IAS officer. He said, bullshit, go to hell. We are more interested in how are you maintaining your hair so much. So meaning, I'll tell you now, that is how your friends will be. He says that only, most people get scared to talk to me. You guys don't give a damn who I am. I said, yeah, that is the whole point. Because we used to fight with him. I used to jump on him and beat him. What IAS officer? So anyways, so we took a ring here. So what is the area of this ring? So area of this ring, here, this is what we did, Vihan. We took a scissor and we cut the ring here. And then this guy became a rectangle. Did you observe everyone? Story is still the same, no? Nothing new. The story is still the same. When this became a rectangle, this guy, the length is 2 pi x and the thickness was dx. So area of the rectangle is nothing but length into breadth. So 2 pi x into dx. All clear till here? Now, what is mass of the ring? Now, mass of the ring, I'll call it dm, is nothing but sigma into area. Now, listen here. I will assume, here, since dx is so small, meaning the thickness is so small, we can assume sigma is almost constant. Sigma is changing, but you took such a thin thickness, sigma is almost same. Isn't that the whole concept of integration? You're taking such a thin rectangle, you can assume the height is almost same, isn't it? I hope everyone is getting this. So you cannot apply sigma into area of the disk. That is wrong because sigma is changing. But you can apply sigma into area of the ring because the ring is very thin. So what is sigma here? Sigma is c into x. What is area? 2 pi x into dx. So what is mass of the disk? Mass of the disk is summation of all the rings. So that is integral 2 pi c x square dx. Where is the first ring starting from? The first ring starts from x is equal to 0. The outermost ring is x is equal to r. So limits will go from 0 to r. So this is 2 pi c integral x square dx from 0 to r. So this would be 2 pi c. That would be r cubed by 3. Did you notice something? This integration was the easiest one. Integration is actually the easiest one. The headache was converting. Is this concept clear, everyone? So the main crux of the whole story was this part. Since you're taking such a small thickness, I can assume sigma is constant. I'll see the only formula I know is mass is sigma into area. The problem I was facing when I took area of the disk, sigma was changing. But if I take a very thin ring, I can assume sigma is constant. Please have a look at the steps. Let me give you one more like this. You can try now. Any step you're not convinced or clear, please ask. This is how we want calculus in physics. You're getting it? Meaning you will encounter pretty good ones later on. Not a single place, meaning you will see it multiple places. You will say this. You guys will get used to it. Don't worry. There was a question here. This guy see. So we have a disk here. They did the same thing. Area of a thin strip. So don't worry too much because whenever this comes again, I will teach you. Even your seniors now, even now they find it little difficult to figure out elements, but by now they're getting used to it. So whatever is being done, grasp it and you'll get used to it. So the idea is this. Right now you'll find it difficult. When I teach you this for the second time, you will think it is 80% difficult. Third time it will be 50%. Fourth time it will be 30%. Fifth time you will say, okay, I can manage now. So in one go you won't get this, but I hope everyone got the crux of it. Clear? Can I ask you a question now?
Sir,
Ah,
can you
record.
just, show the non-uniform disk page like the one previous to this?
Question.
Sir, just 2 minutes.
Ta-da.
Yes, sir, thank you.
Great. Now, what was the last one? Second question. Same question. I'll just change the numbers. You try. We have a non-uniform disk. Sigma is 2x plus 3 kg per meter square. Did you observe one thing? When x is 0, sigma is 3. The radius of the disk is 2 meters. Same thing. So the disk is becoming heavier and heavier as you go out. Find mass of the disk. So you have to do the same question except sigma ka value is now 2x plus 3 instead of cx. Try. Got 2 minutes. Give it a try. How? Any answers? You can use this reference. Check it out. You can use this reference. 41 pi by 3. We have one answer. Anyone else got that? Got an answer? Type in the chat box to the co-host. We have one answer. Others? Hmm. Sixty-eight pi by 3, 23 pi by 3. None of you are matching. 30 seconds more, then I'll show you. 68 pi by 3. We have two 68 pi by 3s. 368 pi by 3s. Let's see. Idea is the same story. I'm going to repeat it again. So take a disk at a distance x from center. Take a thin ring of thickness dx. So we got a ring like this. Thickness x and dx. So this area of the ring will be 2 pi x dx. So mass of the ring will be sigma into area. So that formula is always valid. Sigma into area. Only thing sigma has to be constant. Now sigma is 2x plus 3. Area is 2 pi x dx. So mass of the disk will be, add all the rings. So 2 pi will come out, integral, we'll get 2x square dx plus 3x dx. Limits will go from 0 to 2 because radius is 2. This is 2 pi. That would be 2x cubed by 3. Limits are 0 to 2. This is x dx is 3x square by 2. Limits are 0 to 2. 2 pi, put 2 cube there, that is 8, 16 by 3. I'm skipping steps. That would be 6. That is 18. 18 plus 16, 34 into 268 pi by 3 kgs. Check your calculations, everyone. See where you goofed up. 68 by 3.
Can you show the question?
Oh, this it's like you see the complete movie and then you ask who is the hero.
No, I got in terms of R. I just didn't take the value of R.
Okay. Ever happened to you? You see the entire movie and you have a doubt who is the hero. My sister used to do that. We used to go to movies, she used to sleep. She used to wake up in the break, then she used to eat all popcorn drinks and she used to sleep. Then she used to wake up in the last 10 minutes and ask what is happening. I said, you sleep. That is only better. So she used to come to the theater only to eat. Got your mistakes, everyone? Ahana, got it? Arya, Abhinav, Devansh, Nikhil, clear. Going ahead, next one. Next one. Puruja, go ahead. Solid sphere. Next shape is solid sphere. So we have a sphere of radius r. Now, like I said, the main important thing is how do you choose elements? Now, for a sphere, there are two ways you can choose elements. One is shells. I can't draw 3D, so 2D, 3D will look same. Like, it is thin shells. Like layers of onion. Kabhi onion cut kiya? You'll find onion ka layers. Or the another element is discs. You can take a thin disk, both are right, meaning depending on the format of the question, we can use either of them. But shells are one of the most commonly used ones. Like I said, the most important thing is how are you choosing your limits. So let me show you how to find the volume of a solid sphere. We will use shells. Solid sphere, radius r. So again, same story, from the center at a distance x. Take a thin shell. Unfortunately, it looks like the drinker thing only, but it is not. Just imagine your plastic ball with air inside. So basically, this is a thin, hollow shell whose radius is x and thickness is dx. So what is the volume of this thin shell? So volume of this shell is surface area into thickness. Do you agree? If you take area into thickness, that will give you the volume. So we will call it dV because it's a small volume. Surface area of a sphere is how much? 4 pi x square into dx. So the volume of the sphere is what? Add all the small cells. This is 4 pi x square dx. Your shells will start from 0 and end at r. So this is 4 pi x cubed by 3 from 0 to r. 4 by 3 r cube. Got the volume? So that is how you choose shells for a solid sphere. Clear, everyone? I hope you're getting the ideas by now. So basically, depending on the shape, you have to choose an appropriate element. So basically, when you add those elements, you should get the full shape back. You can't take a square elements right here. Doesn't make sense. You can't take cylinders. So shells are appropriate. Discs are appropriate. Disc is like this. Did you ever cut a watermelon like this? You'll get a disc, isn't it? The green color band and the red color fresh in the middle. Let's see a question on this. Non-uniform solid sphere. So we have a non-uniform solid sphere. The radius is 2 meters. Rho is volume density, which you studied in school, which is mass by volume. So rho is given, rho is equal to 3x. Meaning at the center it is 0, and as you go outside it increases. Rho x is 3 kg per meter cube. X is distance from center. Find the mass of this sphere. X का value lies between 0 to 2. Let's get this. Any answers? 30, 48 pi. Yeah, we have a lot of 48 pies. 1, 2, 3, 4. 4 48 pies we have. 5 48 pies. Okay, let's see. I think most of you got that same. Again, idea is the same. At a distance x, we will take a thin dx. So the volume will be surface area 4 pi x square into dx. So mass will be what? Mass will be density into volume of the thin thing. Again, same idea here. Since thickness is so small, you can assume rho is constant for the thin shell. Only for the shell, not for the whole thing. Since thickness is so small, we can assume rho is same. Thin shell. So rho is how much? 3x. This volume is 4 pi x square dx. So mass of the sphere would be integral dm. That would be 12 pi integral x cube dx from 0 to radius is going from 2. 12 pi, that would be x power 4 by 4 from 0 to 2. That would be 3 pi into 2 power 4, that is 48 pi k's. Yep. Don't you think integration is the easiest one? And the whole problem, the integration was the easiest thing. Finding the element was a messed up thing. All clear with this? So this is how you can find masses of non-uniform stuff. Let's do something even better. Any doubts on this page, please ask me. Others, check it out, see where you went wrong. Surya, got your mistake? Yeah. Next one. So if I have to ask you a question in advance. So we have a hollow shell partially filled with liquid. You're getting? The entire thing is not filled. It is only filled up to height h. R is the radius. Find the volume of the liquid. This red thing is the liquid. Now there's no formula for this, right? We know the formula for full sphere or a half sphere. We don't know the formula for something like this. So first thing, how will you take an element? Think about it for a minute. Then I'll ask you something, and then let's see. Think for a minute. Don't worry about getting the answer. Think about what should you do? How will you take an element? How do you think you'll figure it out? Think. Take a minute. Now let me ask you something. Did you figure out how to take the elements? How? Can I take a shell? That's a bad idea, right? It doesn't work. Why? Because there's no liquid only here. What will you take a shell? So what's the best thing to do? You have to choose discs, na? You're getting it? So choosing a disc is a good idea here. That is one. Okay. Now let's say this question comes in the exam. Now listen carefully. How will you guess this? If this question comes in the exam, how will you guess this? This is important. That's what I was saying. Like, guessing requires more knowledge. How will you guess this? Any ideas? Normally, this is what I do. If you give me a question, the first 10-15 seconds, I will see if I can guess this. The moment I realize I can't guess this, I'll start solving. And guessing is a skill that will come with time, and it requires more knowledge about thinking different possibilities. So when I was in 11th and 12th, now my friend Sabir, right, he is pretty good in physics. He's the one who actually taught me multiple concepts. But Sabir never scored more than me. You're getting it? Because problem is Sabir is always slow. Sabir can't guess. Sabir, if you give him a question, he will think about it. He will logically sub sochta hai every possibility. But when it comes to exam, he's pretty slow. So when we wrote the AIEEE exam, 2006, my rank was All India 185. Sabir rank was 9,000. When we wrote JEE exam, my rank was 360. His rank was 670. So as the exam became tougher and the questions are getting more time, he started shining better. So if it is a physics Olympiad, right, I'm sure he will do better than me. Because physics Olympiad, I have only 3-4 questions for 3 hours. So how to guess? I'll give you an idea. See, tell me one thing. If h is equal to 2r means what?
Height
If
is
h
double
is
the
equal to
radius.
2r, meaning full भर गया ना ये? If h is equal to 2r, meaning the whole sphere got full. If the sphere is full, what should be the answer then? 4 by 3 pi r cube. So what will I do? There are 4 options in the exam. I will put h is equal to 2r, h is equal to 2r, h is equal to 2r, h is equal to 2r. Whoever is not giving 4 by 3 pi r cube is wrong, na? Are you getting how to guess? See, whenever you are guessing, you cannot find the right answer. You can find the wrong answers. And if you can eliminate 3 wrong answers, automatically 4th is the right one. Can you tell me something else how to guess? What else can I do to guess? So this is one. What else? Suppose if I keep h is equal to 0, what should I get? What do you mean by h is equal to 0? There is no water,
liquid.
right? So what should be the volume? 0.
0.
So if you keep h is equal to 0 in the option, 0 आना चाहिए. Can you give me anything more? So the idea here is you have to convert the problem into something which you already know, and then from there you try to guess. If h is equal to r, what will you get? Half filled, na? So if half filled, what is the volume? 2 by 3 pi r cube. Means in your options, if you keep h is equal to r, I should get 2 by 3 pi r cube. Is this making sense? This way, you'll be able to eliminate at least 2 to 3 options. If you're lucky, you can eliminate 3 options. So whatever is left is the answer. Are you getting this? So whenever you guess, you try to find the wrong ones. You can't find the right one. That's the idea about guessing. Let's see how to do this. Now, Vihan, you typed some answer. Now check. If you keep h is equal to 2r, are you getting the answer?
Yes, sir.
You're getting. H is equal to 0, you're getting 0.
Yes, sir. Because
H is equal to 0, you're not getting 0.
sir, how come? Sir, 2h is there. H is there in the numerator. So if h becomes 0, then the entire thing should become 0.
If you keep h is equal to r, I
Sir,
think did you set up the answer?
yes, sir.
Yeah.
Sir, actually, I thought that if like h is equal to 2r, then it's the whole thing. If h is equal to r, then half. So then I just took a fraction by saying h divided by 2.
So yours is a case, operation failed, but patient survived.
Yes, sir.
Let's see. Now let's see how to do this thing. But I hope everyone got the idea here, right? Now just imagine in an exam, right? If you can guess even 2 to 3 questions like this, it saves you a lot of time, right? See, so this is how we do. Listen carefully. It's not tough, but again, you should know how to choose elements. So the liquid is still here. So from the center, at a depth y, I will take a thin disk. Whose depth is dy. Are you getting it? So consider a disk of thickness dy. So for this disk, this is radius r and this is x. So using Pythagoras theorem, we have r square is equal to x square plus y square. Basically, your x is the radius of the thin disk. So now if you take out the disk, isn't how this disk looks? Where this is the radius x and this is the thickness dy. Can you see something? Doesn't this look like a small cylinder of radius r and height h? So for a cylinder, this is like a small cylinder. What is the volume for a cylinder? Pi r square h, agreed? So I can use the same logic here and say, So dV, so volume of this thin disk is pi into x square into dy. Everyone clear with this? Now, what is y here exactly? At the center, y is 0. Now, if you look at the water level here, so y is the distance from the center. Can you tell me when is the first time you're touching the water? When does the water start? When y is r minus h, isn't it? When does the water end? When y is equal to r. So what are the limits? From the point when water starts to when the water ends, isn't it? So volume of the liquid will be summation of all the small volumes, which is integral pi x square dy. Limits will go from r minus h to r. So this is pi, but what is x square? R square minus y square. So I just took this and substituted here. Have a look at till here. I'll show the integration in the next page. If you got till here, we are done. Now it is just a matter of integration. Again, see how did I choose the element? At a depth y, I took a thin disk of thickness dy and radius x. So this thin disk is behaving like a cylinder whose volume is pi r square into h. R ka place mein x is there, h ka place mein dy is there. If I add all these thin disks, it will add up to the liquid. We know. Any doubts on this page? Please have a look at this. Clear? Next thing. Now let's integrate this. Now integration is easy, but it's lengthy. So pi integral r square minus y square dy. Headache is the limits are not that neat. But okay. Maybe if I have taken y from the bottom, it wouldn't have made a difference. So let's integrate this. The integration is actually the easiest part. Integral r square integral dy minus integral y square dy. Limits will go from r minus h to r minus h to r. So this integration is simply pi r square, that will give you y. Limits will go from r to r minus h minus y cube by 3. Limits will go to r minus h. So this is r square, and this would be r minus of r minus h minus 1 by 3 r cube minus r minus h whole cube. Expand this. So this would be pi. So that is r will cancel. You end up with r square h minus 1 by 3. This would be r cube. Everyone knows a minus b whole cube expansion. So that would be r cube minus 3r square h plus 3r h square minus h cube. R cube will cancel. This guy will go off. This would be r square h. That minus will multiply. You end up with r square h plus r h square minus h cube by 3. This guy will cancel again. You end up with pi h square into r minus h by 3. That's your answer. So this is the volume. I'll do one thing. I'll write down the answer here. So this volume would be pi h square r minus h by 3. So that's your answer. Now let's verify and see. If h is equal to 2r, substitute there, we will get pi 2r whole square r minus 2r by 3. So this is one thing, Rehan. Just because your answer matches for 2-3 things doesn't mean it's right everywhere. So that is right. So if h is equal to r, we get v is equal to pi r square 2r by 3. There. At least the options are matching. So the problem with guessing, if it is wrong, it is wrong. If it is right, there is no guarantee it is right. It's like if you don't study, you won't get into IIT. If you study, you may or may not get into IIT. That is the point. Please have a look at the integration. This is not tough. It is just lengthy. Is the integration really tough? Tell me one thing. This part. X power n integration, only when you keep the limits, it became little lengthy. Please have a look at the steps. I hope now you have some respect for integration. You can find volume of even weird shapes like this.
Can you show the previous page?
Anyone not convinced with this, please ask me. I'll send you a small sheet on something like this, 4 or 5 questions.
Thank you, sir.
Have a look at this. This is how we want to learn calculus in physics. We are not interested in the big integration. That is all max. They'll do that. We are more interested in finding volumes, masses, and stuff. So in exam, how they'll ask you this question: find the potential energy of this liquid. School में किया ना gravitational potential energy. They'll ask you something like that. For that, you need mass, right? mgh. All clear with this? Anything that you're not clear? Ishana? Clear? Pratik? Abhinav? Ojas? Clear? Vignajit? Ahana? Ansh? Adi? Daksha? Clear with this? Jainil? Niharika? Surya? Perfect. Now you guys try this thing then. We have a solid cone. Radius is r. Height is h. Find the volume using integration. So first important thing is how will you choose an element? From there start. Everyone knows the answer, right? Volume of a cone. So we need to prove that. You got it? Let's see. Try. Others, give a minute. I know you know the answer, na. So, how did you choose an element? That is the main thing. How did you choose an element? Yeah, disc. Did you ever cut a carrot? If you cut a carrot, how will you get? You get this thin discs, na? Doesn't it look like a kind of a carrot? So we have to add all these discs, isn't it? If you add all these discs, you get the thing. So idea is the same. You have to choose a disk. That's a catch in this. So here the elements are thin disk. Is like cutting a carrot. Try. I'll give you a minute. Others, give it a try. Just give it a try. I'll get some water and come. Let's see. So we have this thing. So at a depth y, take a thin disk of radius x. This angle is theta. Now we know for the cone, this was r, this was h, this is also theta. So from similar triangles, we know tan theta is r by h, that is also x by y. Agreed? Now for this thin disk which you have taken, again, if you see it kind of looks like cylinder whose radius is x and whose thickness is dy. So understand one thing, if you are going in the direction of y, you should take dy. Y ka small thickness you are taking. So the small volume of this disk will be pi x square dy. But what is x? X is ry by h. So y r square y square by h square dy. So what is the volume of the cone? So volume of the cone is integral, add all the small volumes, which is pi r square by h square integral y square dy. What is y ka value? So at the topmost point, y is 0. If you keep coming down, y is h, na? Where is the last disk? At the bottom, y is equal to h. So the limits will go from 0 to h. That is the meaning of this. Y ka value is changing from where to where. So this is pi r square h square. This would be y cubed by 3. Limits will go from 0 to h. So pi r square, 3h square. This would be h cubed by 3, h cubed. So 1 by 3 pi r square h. Alright, Surya, Pratik did the same. Great. Others, check it out. So this is the idea every time. You take a thin disk, radius will be pi x square into dy. Get x in terms of y, substitute, and you're done. You'll get the integration. So if you think about it, this problem and the previous problem, they have kind of same similarities, right? Even though the shapes are different, end of the day, this logic was same, na? Volume of thin disk. This idea was always the same. Please check. Clear with this? Everyone got this? Ojas, clear? Arya? Clear, no? Vihan? Arnav? Daksha? Clear, no? Ahana? Got this? Great. Next one. This is quite important, right? Matlab, you can put a star for this. You definitely have to mug up this result. It will come in at least 4 to 5 chapters. So we have a sphere. So this part of the sphere, you painted it. This angle is theta. R is the radius. So I don't want full sphere. I just want that area of the shaded part. I don't want the full surface area. Can you guess the answer? How will you guess the answer? Can someone tell me? Meaning for different thetas, you get different areas. How will you guess the answer? Think about it. If theta is equal to 90, means what are you doing? If theta is 90, means aren't you taking half disk, half sphere? So for half sphere area कितना आना चाहिए? 2 pi r square ना? You're getting? So in the options, if I keep theta is equal to 90, whichever option does not give 2 pi r square is wrong. I don't know the right one. If I put theta is equal to 180, that means what will happen? You're covering all the rings, isn't it? You should get full surface area, no? Are you getting the logic, everyone? How to guess? So you need to check for what theta, how does it look, and then you see which options are not matching and eliminate them. That's why I keep saying, guessing requires more knowledge. You should know how things will change when you change theta. But how do we integrate this? Try, give it a minute, and I'll show you. It's a little different. Unlike all the shapes you have seen, this is a little different one. But you think for a minute, then I'll show you. The result is more important. And don't worry about all these things. All these things, again, when they come, I will teach you again. But like I said, you need to have an idea. This is what we're looking in integration. So if you have seen this once, second time it will be more easy. So while doing some new chapter, if you encounter this and the new topics, the whole thing will become very complex. See, listen carefully. This is a little different from the regular ones. So we have the sphere. So I'll just take part of it. So this is your center. So what we are going to do now, from here, somewhere in the middle, at an angle alpha, take a thin slice, d alpha. You're getting it? How does this thing, look? Able to visualize how it is? Think like this. Take a watermelon, cut it horizontally, you'll get a disc, right? And from the center, remove the red color flesh. What do you see? A green color band. Able to visualize? You take a watermelon, cut it horizontally, you'll get a disc. From the disc, remove all the red color part, and what's left is a green band. So this was the radius r. This was angle alpha. And this was a small thickness d alpha. So this width will be r d alpha, arc length. This will be r sine alpha. So now if you cut it, and if you open this, you will get again a rectangle. The story is always the same. Where for this rectangle, the circumference will be 2 pi r sine alpha. And this width will be r d alpha. Please have a look at this point. If you cut this ring, this entire circumference will be 2 pi r sine alpha, isn't it? And the width will be r d alpha. So the area of this thin disk, area of this thin ring, basically the surface area, is length into breadth, which is 2 pi r sine alpha. That is your length. And breadth is r d alpha. So this is your area. Now, what about the limits here? If you look at the limits, at this point, alpha is 0. At this point, alpha is theta. Meaning for different values of alpha, when you go from 0 to theta, you're getting different rings. So therefore, the area of the shaded part is summation of dA, which is 2 pi r square sine alpha d alpha. Limits will go from 0 to theta. 2 pi r square comes out. You end up with sine alpha d alpha, which is a simple integration. Sine alpha ka integration is minus cos theta. So 2 pi r square, substitute the values, you'll put cos theta, cos 0. So that becomes 2 pi r square 1 minus cos theta. That's a result which you should definitely mug up. Exam, you won't have time to do this. So we have area of the shaded part is 2 pi r square 1 minus cos theta. Remember, theta is the half angle. Please have a look at the elements. The main idea is getting that element like that. And you can verify your answer here. See, if I put theta is equal to 90, cos 90 is 0, 2 pi r square, na, half area. If I put theta is equal to 180, cos 180 is minus 1, minus or minus plus 1, 2 into 2 pi r square, 4 pi r square. Please look at the integration and the elements. Anyone not clear with any particular step, please ask. Clear? Any doubts? Anyone not convinced with this, please ask. How was just clear? Getting how did we take the ring and the element?
Yeah, sir, could you repeat how did we get 2 pi r sine alpha?
The radius is r sine alpha, na?
Okay.
This is r, na?
Yeah.
This is r, right?
Yeah.
So in this triangle, this opposite side is r sine alpha. So r sine alpha is the radius of this ring. So 2 pi r sine alpha.
Okay, got it.
Others, anything that you didn't understand, small things, anything, ask. You guys didn't expect ना integration ऐसा होगा? People got tired. So I'll just show you one example. See, meaning, suppose if someone gives you a hemisphere like this, and let's say this much part is some coated, and this angle is 60 degrees. So using that formula, we get shaded area is 2 pi r square 1 minus cos 60, which is pi r square. So that surface area is pi r square. Getting it? That's how you have to frame this thing. So the questions will be framed like this. The first time you'll encounter this is in friction only. There we see how this thing. This was the question. See, someone sprinkled a dust on a hemisphere and the dust got stuck here. So there was a frame like that. The question is find the area covered in dust. So you should know this result. So that area is pi r square. So somehow we will find the angle 60 using physics, and then we use the formula to get this thing. Getting applications will be like that. So that result is like a genuine thing you should know. Any doubts on this? All clear? Now, I'll give you homework. Make sure to try this thing. Similar one, not similar, different one. If we have a paraboloid, a shape like this. Think of a sweet potato. Ever eat a sweet potato? You break into pieces. So it looks like this only, kind of. But I'll show you a better example than sweet potato. So this is your x-axis, this is your y-axis, this is 0, 0. So this curve which is there, this curve ka equation is y is equal to h by r square into x square, where h is the height of this paraboloid and r is the radius of this paraboloid. So the question here is find the volume of this paraboloid. So I want you to find this volume, this entire volume. Let me show you how this looks. Where do you get the shape? Did you ever, rotate the water in a bucket, or did you ever rotate some liquid with a spoon in the glass? That is, that is the shape you get when you rotate water. When you rotate, the water in a bucket, you get shape like this thing, isn't it? It forms a bowl kind of shape. To be more graphical thing, there, it kind of looks like this. Able to visualize now? You must have done this, right? Put your hand in the bucket and rotate it. You will see the water becomes a bowl shape kind of thing. This is the shape we get. That shape is actually paraboloid. Getting rotated in a container, the shape we get is a paraboloid. So I want you to find the volume of this paraboloid. Clear? So try this much. So this thing we will discuss in the next class. So in the next class, Vihan.
Sir, here y means like y on the
The y coordinate.
not the inner side.
No, meaning यहाँ पे ना, this is the x, y coordinate.
So sir, is this a 3D figure or a 2D figure?
It's a 3D figure, but I gave you a 2D equation.
Okay, sir.
Same होगा ना, क्या फर्क पड़ेगा? End of the day, what you're interested is this x square only. It's a 3D figure. मतलब there is a thickness like this also. Z direction में भी है thickness, but it will be same thickness in every direction, na? So if you can find in x, y, it will be same in z also. ठीक है? ठीक है. So that's the last one for the day. Now we will discuss the paper and that assignment ka doubts. So first, any doubts in today's class notes, you can ask me.